Good evening. Just thought I'd do some messing around with diodes today. I know in a previous video I've said that diodes don't do anything except sit there. Well, it's not strictly true. What they do is they rectify current, or they change the way electricity works. I'm just disconnecting that and I'm going to put that on AC, so I'm measuring it at the same side as the input. What we have here is we just have these two white wires are coming from a transformer just off to that side, and it's all highly dangerous and terrible and nasty, and and it's 4 o'clock in the morning, so I really don't mind. And what we have here is we have the little cheap oscilloscope and my multimeter, which I've currently got set to AC. I didn't just press hold there, did I? No. It's just set to AC, and it's measuring what's coming straight out of the transformer, and this is showing the AC waveform. And as you see, you get a full signal straight in, straight out, and every one of these peaks is happening at a 50th of a second. It's 50 times a second. 50 hertz is the mains frequency in the UK, and as you see, each sort of start to up to back down, that would be one complete cycle. So what we have here is we have 1, 2, 3 cycles displayed on the screen, and it's showing you that it is completely going from 0 to minus to plus, through 0 again back to minus, and then resting at 0, and then back up, and it does that as long as the electricity is connected. But AC is not very useful for doing electronics. A lot of the projects, well, in fact all of the projects we've done in the Lunchtime Electronics series have all been DC based. There's not much in your household that doesn't run off DC in one form or another. Even the LED light bulbs that everybody's gone over to do convert AC to DC, and run at DC as well. All your stereo is DC internally. It's just easier for the electricity companies to supply AC and let us convert it to whatever we need in whatever appliance. They only have to supply one standard then, rather than multiple standards. So what we've done, as I say, we're just measuring there. Now, to change to DC, what we need to do is we need to do what's called rectification, which means it rectifies it from a swinging signal to a not swinging signal, or one that swings a lot less. And the way we do that is we do that with a diode. So what I'm going to do is I'm just going to take that off there and connect it this side, and flick that to DC, and then I'm going to take off the scope probe and show you what's happening the other side of the diode. And there we go. We've lost pretty much all of the zero, all of the negative side of this waveform. So now, instead of seeing 3 complete cycles, we're seeing 3 half cycles. We're going from 0 up, back to 0, and then staying at 0 until we go up and back and up and back, and that's half cycles. And each of these peaks is still 1 every 50th of a second, or 50 hertz, 50 cycles per second, but you're only getting half of it. Now, using a single diode like this is called half wave rectification, because you are only rectifying half the waveform. You will also notice that the voltage has halved, because compared to the AC side, because only half the electricity is coming through the diode, only half the voltage is measured, as well as half the signal. So that could be a little bit of an issue if you're looking for sort of more voltage, and it seems silly to sort of have 36 volts at this side and only 16 at this side of a diode. So what you have to do is another technique called full wave rectification. Now the way you do that is not with one diode, but with a group of 4 diodes, which make what's known as a bridge rectifier. Now the bridge rectifier is actually quite a common thing. You see it drawn on circuit diagrams as 4 separate diodes, but you can get them in wherever I found them. You can get them in this form, or you can get them even when they look like this, which again is 4 diodes. And as you see, they will all work in exactly the same way. They're all bridge rectifiers. Let's have a look. That one's plus. That's the AC. That's the AC. And underneath this sort of gooey gunk, all you have is 4 diodes. In this package here, all you have is 4 diodes. It's just that they're laid out in a different format. So if I take those away, and let's stick with the 4 diode format, we have to then figure out which way they connect. Now, always the AC goes in the middle of the bridge, and you can tell the middle because the 2 diodes on that side and the 2 diodes on that side point the same way, so everything's pointing forwards. And that then means that we can connect the plus to the end, if I can get that in there, and if I put the oscilloscope probe on it as well at the same time, and the minus will go at the other end, which is here, as you see, because the scope is picking up noise at the moment. There we go. And then we just plug the AC in halfway across the bridge. Drop that diode, plug that in there. Now, what we have here is we've returned to very close to the original voltage, and there's a reason why it's dropped, because each of these diodes has a voltage loss. But we've also now got 6 peaks on the screen, because all the negative side has been turned positive. So we've actually made it slightly more efficient in that respect. So we're getting more positive voltage and no negative voltage, which shows that you're getting a more efficient sort of rectification for your power supplies. Now, obviously, if you're going to make a power supply, you then have further stages to do. You need to put in filtering and, work out the resistive loads and everything else. And I'm not going into the maths at this time of the morning, but I thought it'd be interesting to show you that a bridge rectifier actually doubles the frequency of the AC signal put in. So if we were putting 30 Hertz into here, this would be reading 60 Hertz now on the outside. As we're putting 50 in, this is actually set now to 100 Hertz. So you're doubling the frequency because of the way you're rectifying the DC voltage, or rectifying the AC voltage and turning it into DC. Because you're taking all of the negative and making it positive, it's actually called full wave rectification. And as I say, you'll see it listed on circuit diagrams as such. There are benefits and disadvantages to both, and I could go into them, but to be quite honest, this is a basic what do diodes do and a simple look at rectification. If I started to go into what's more efficient and how much current do you get and how much voltage, I could baffle you with maths. What the general sort of specification is that if you run a bridge rectifier like this just into a resistive load, your output current is about 90% of what the transformer's rated at. You can only get about 90% out because of the losses in the rectification. On the half wave rectification, you can only actually draw about 65% from the transformer. So if you've got a 1 amp transformer and you're only half wave rectifying, you could only get, as I say, around about 60%, so 600 milliamps out of a 1 amp transformer, and also you would only be getting half the voltage. So not only do you lose out on your voltage, you lose out on your current as well. It all goes down to Ohm's law and all the other bits and pieces that go with it. As I say, I'm not going to baffle you with maths, but needless to say, if you're actually looking for efficiency, you're better off using full wave rectification and getting the 90%, as opposed to with a single diode only 60-65%. Thanks very much for watching. Hope this has been informative, and I hope I've not dumbed it down too much, but I thought it'd be interesting to look at the two different types of rectification using just diodes and nothing more than very cheap equipment to show you the results. Well, multimeter, cheap oscilloscope, and it is actually just 4 or 5 diodes I've used in this, although I did cut one up to get the legs for the transformer. If you like what I'm doing, please subscribe. If you don't, tell me what I'm doing wrong, and hopefully you'll come back and watch some of my other videos. Thanks very much, and we'll see you again soon. Bye bye.